no! What happened?
So we bought 3 bunnies. Like it was a while ago. We got 3 bunnies. We thought they were all girls. But
There was a buck in there.
There was my sister's bunny's name was like Andrea, but it turned out to be like Andy because it was a dude. So they were siblings, and it got mine pregnant, and then my bunny had like 10 baby bunnies, and then like Andy killed the 10 bunnies, and then like
oh yeah,
she got like cooked because he like tried to. So she had to like go to the hospital, and we gave her like ointment. I don't know. This was a couple years ago, but on Easter morning, we like got a call from our friends that were like taking care of it. She said it died, so she left it in a Walmart bag, like in our lawn. And we came back like 3 days later. It smelled so bad.
Wait, why did they? It doesn't know. Wait, Walmart?
that's what we're gonna do to Hazel.
You have to tell us this.
Whoa!
No.
This was 2 years ago,
Oh
or this was this year? The Walmart.
no, this is like I don't know. It's probably 12, 13 maybe, 3 or 4 years ago.
Horrible. Oh, I think you had the bunny. Cinnamon. Wait.
I thought Cinnamon died yesterday.
Yeah, same.
Or not yesterday. It was,
Yesterday
it was on Easter morning.
Oh, like 3 years ago.
Oh.
Yeah, different Easter.
Oh, I thought you still had this bunny.
Yeah, I also still had the
Oh,
bunny.
now I'm not sad anymore. This was years ago. Wow, that is an amazing story. Very good. Oh, that's awesome. Awesome. Okay, let's crank out 12-4 real quick. Get your calculator out. Find, so this is mostly calculator, actually all calculator work. Find each function to for sig dig. Sig dig meaning significant digits, which means you would have 4 digits that are significant. You would have to remember, are leading zeros ever significant? Leading zeros ever significant?
Wait, no.
No. Trailing zeros are significant if there is a decimal. Yeah, trailing zeros are significant if there's a decimal. All of these will have a decimal. So all you're going to be doing is take your calculator, make sure it's in degree mode, 38.7 degrees, DEG. If you want to double check that it's in degree mode, you can look and see that it says like D or DEG. If it doesn't say that, just to check it, you all know what the sine of 30 degrees is. All of you do, without a calculator. You all know the sine of 30 is 1/2. Yeah, so you could punch in your calculator sine of 30, as long as it gives you 1/2, you know you're in degree mode. And if it doesn't give you 1/2 for the sine of 30, then you're like, okay, I gotta get the mode changed. So we do cosine of 38.7, and what do we end up with?
0.7804.
Okay, 0.7804 degrees. Included zeros are significant, so we get that done. Then, what happens when we take a look at this one? Okay, sine of, let's say, 287 4 degrees, like that. Okay, so now this is, it's not an acute angle, so we go sine of this, and again, not difficult, just punch it into the calculator, and we end up with a
Negative 0.9542.
0.9542, and it's negative, which makes sense for us, because what quadrant are we in with 287? Fourth quadrant. Now, let me give you the tip. This type of problem will be on like the MCA or the test. Usually people have no problem. But then you'll see one like we were working with in 12.3 that it'll say, you don't have to write this, it'll say write as a function of an acute angle. Okay, and it'll have sine of 287.4 degrees, and people just punch this into the calculator, they give us this answer, and it's like, no. This is not asking for the value, the ratio. It's asking for the acute angle for this, which would be the reference angle. So we would not do our calculator, type it in. We would say, oh, what's the reference angle for this? So that, like, might as well do a little review. What's the reference angle for 287.4? What's the reference angle for that?
17.4.
No, it's always between the terminal side and the
Oh.
x-axis, not the y-axis. So 287.4,
72.6.
72.6. And then you recognize, though, this is negative, because it's quadrant 4. This is positive, always will be positive when it's an acute angle. Therefore, what do we have to do in the beginning to make them equal? You just put a negative up front. So pay attention to that. Are they asking for right as a function of an acute angle, which would be this, or are they asking for find each function, so actually find the ratio? Okay, it's not tricky, you just have to know which one they're asking for. This one is nice, just a calculator and you're done. Now, you're gonna get ones like, do we have that? Good, we have this one. Let's say the CSC 27 degrees and let's say 40 minutes. 27 degrees, 40 minutes. Okay, cosecant, do you have cosecant on your calculator? No. But what do you have on your calculator? Sine. And so you think about this and just say, okay, this is on your calculator. You would go 1 divided by sine. And now what's interesting here, guys, is people do this. They actually just leave it like that. They're like, okay, did the reciprocal. Well, yeah, but now you need to use your calculator. Now the other thing is sometimes you have a conversion to do, right? So how do you convert 40 minutes to decimal? Because some calculators will have decimal minutes available or degree minutes, I'm sorry. You could punch that in your calculator, but a lot of them don't. So how do we convert this?
Divided by 60.
Yeah, just take 40 divided by 60, right? So you, however you do your conversions, 1 over sine of 27, plus 40 over 60. That's what I would do on my calculator, because your calculators have amazing ability to, calculate all that in one fell swoop. And so I would just go 27 plus 40 over 60, then you don't have to do any rounding as otherwise. Now you could get away with, because 40 over 60 is 0.6, right, repeating. So you could, I'm sure your decimals would be, I'm sure you're going to get the right answer if, you just typed in like 4 6s, you're going to get probably close enough. You're not going to, that's a pretty accurate estimation. So if you want to do that, what do we end up with?
2.153.
2.
2.154, I guess.
2.154 for significant digits there. Okay? Now, this says find, I think it just says find theta. So this is to the 10th of a degree. Find theta to the nearest 10th of a degree. We'll call this number 4. And so we're going to have, let's say, the cosine of theta is equal to 0.75. So now, what we've kind of done before is we've looked and we said, okay, cosine theta equals x over r. So I could have a ratio, I could find sine, I could find tangent based off of a right triangle with already knowing the ratio. But now they're like, no, you just want to find theta. You're not trying to find your other 6 trig functions. You're just trying to find theta. So we do this, if you recall, by doing the inverse cosine button on your calculator, which is to the -1. Okay, so what you do is you take the cosine inverse of both sides, and essentially cosine inverse and cosine essentially cancel, and then theta is equal to cosine inverse of 0.75. So you find the inverse button on your calculator. Some of them you have to double tap a button. I think those ones you do, right, Commander? So you double tap it, and then you end up with
41.4.
31.4? 41.4 degrees. We feel good about that. Okay, so not difficult there. It can get a little difficult when you have something like the secant, and this isn't like really difficult, but you have to work through it. Secant of theta is equal to, let's say 3.47. Again, do you have an inverse secant button on your calculator? You do not, but what do you have on your calculator? Cosine. Now, before you hit inverse cosine of both sides, this is not cosine. This is, what is this? This is 1 over cosine. So again, you can't just hit inverse cosine because this is 1 over. It's not the same. It's not cosine. It's 1 over. So what you need to do is get it to where it's just cosine theta equals something, then do the inverse of both sides. Often miss, people take inverse cosine right now, and they're going to get it wrong. So you need to, if you recognize this, you could like cross multiply and then divide, or when you have 1 over equaling something, just flip both sides. If it's just 1 over. So then it's just cosine theta is equal to 1 over 3.47, like that. So with these, you can, as long as it's 1 over. Now, if this was like 5 over cosine theta, it would be then, you know, you could flip both sides, but it'd be cosine theta over 5, and then you'd have to multiply both sides by 5. Just basic fractional work, cross multiplying. But since it's 1 over, we just flip both sides, and then you take inverse cosine of both sides, and what do you end up with? Now, make sure you're doing inverse cosine of the whole fraction, 1 over 3.47.
73.2. Wait, yeah, 73.3.
73.3 degrees.
Yeah.
Okay, which would make sense. And it makes sense in my mind, and you know, again, I've taught this for a long time, and I understand the unit circle and things like that. But it makes sense that we're getting a relatively large angle on that. And the reason for that is this is saying the cosine of 1 over 3.47. So in that cosine is x over r, right? So x over r, you know, if you're getting, this is a smaller ratio, because 1 divided by 3.47 gives you a smaller number. And if you're getting a smaller number, it means your x value compared to your r value, right? Your r is a lot bigger than your x, therefore your r is a lot bigger than your x. Versus if you had a triangle like this, where your x value is close to your r value in length, right? This length and this length, then your ratio is going to be closer to 1, and so you have a smaller angle, you know. So if this was, you know, cosine theta is equal to 1 over 1.1, let's say. Now, when you do that, you would expect to get out a small angle because your ratio, your x compared to your r, x and r are getting close to being about the same thing, which means your triangle is getting really small. You don't have to think through that, but it helps you if you start to grasp that. It can help in your understanding. Okay, there are some that says to the nearest minute, but I don't think I think we understand. If you wanted, if you wanted to find this to the nearest minute, you just find the degrees and then convert it. Hopefully we're comfortable with our conversions on minutes and decimals. So I'm going to skip that. Now this one is the tricky one that will require you to understand trigonometry at the next level. Find 2 angle measures. So far we've just had to find 1, right? Now, meaning like with 4 and 5, we just found cosine 73.3. So now it says find 2 angle measures. You're going to have the same setup. Let's do just like sine theta equals. Okay, so you're going to have the same setup. And let's go like negative 0.85. All right. So now, calculator, great. Do the calculator. Now that's what you're supposed to do. So this says find 2 angle measures. So when you go to do the calculator though, it's just going to give you 1 angle measure, right? At least that my calculator only gives me 1. So you do inverse sine, what do you end up with? Theta is equal to?
Negative 58.21.
Negative 58.21?
Yeah.
Now, they did say, I'm sorry here, theta needs to be between 0 and 360 degrees, like this. Okay, so the negative 58.21, we're just going to have to do a conversion so that angle measure falls between 0 and 360. So here, like a little picture can be very helpful. Okay, the picture that's helpful is this, okay, I got out negative 58.21. For starters, I know my angle needs to be between 0 and 360. And then I have to figure out 2 angle measures. Let's start with getting this to be a positive angle measure. Now, to make it positive, you don't just make it 58.21 because, think about this with me, If you have a negative 58.21, it means we went down like that, right? So there's negative 58.21 degrees like that, right? So if you said, well, I'm just going to make it a positive 58.21 like this, well, the issue is those triangles have the same dimensions. The issue, though, is that out x, but then we are going which way with my y? Negative y value, right? And here I go out, and then which way am I going with my y value? A positive y value. So if you change it, then the sine of theta, if you just change it to 58.21, you know, if you said, okay, well, the sine of 58.21, that's going to equal a positive, where you actually want it to equal a what? Negative. So make sure you go, okay, I go this direction. If I want my angle measured in between 0 and 360, I go all the way around to right there, right? And so then what is that angle measure? You would just go 360 minus that, and you end up with what? Theta should be 301.79 degrees, right?
Yeah.
Okay. Now, and maybe this is the nearest tenth, that's fine. Let's go with 0.79. We just subtracted from 360. So now, if you do sine of 301.79, it's going to be the same thing as the sine of negative 58.21. You can double check it. Now, these are rounded, so it won't be exact, but you'll get something really close to 0.85, negative 0.85, right? So there we go. So that's our, okay, that's one of our angles. So on like the test, you'll get 1 out of the 4 points. And the reason why you only get 1 out of the 4 points is that they are asking for 2 angles, and this is more than just punching into the calculator. Like, you know, this, just hit the calculator button, you get this. Now we have to understand, oh, there's more to it than just one angle measure. The reason for that is, you remember, reference angle, remember, there's 4 triangles that actually all look the same, and they all, you know, if we were to draw them, they all have a 58.21, 58.21, 58.21, and 58.21. All of these triangles are the exact same in terms of the dimensions. It's just that their x's and y's are positive or negative. So there are actually 2 triangles that will yield for us that ratio. Okay, we just found this triangle, right, yields that ratio because of the negative y value. Where's the other triangle that yields a negative ratio for specifically sine? Okay, sine in quadrant 1, what is sine going to be, positive or negative? Positive. Sine in quadrant 2, positive or negative? Positive, because remember, sine is y over r. Y values are positive. What's my y value going down here now? Negative y. And so then this is the triangle you want to consider. And so how do I remember? I can't just say 58.21 because it's based off of starting here and going around to right there. So how do I find out what that angle measure is? Not too difficult, right? Because we just go from, I mean, to get there, it's kind of difficult, but once you get here, you go 180 plus how many more? 58.21, so you get 238.21. Now, to double check this, what can you do on your calculator to double check that you found the 2 correct angles? Take the, remember what you're finding theta. Take sine of 301.79, do you get approximately negative 0.85? Take sine of 238.21, do you get approximately negative 0.85? You will. If you did your math correct. You got it? So, you know, that type of problem is definitely, it's not just like easy. It requires you to understand right triangles in 4 different spots, understand subtraction from 360, understand ratios of negative y values over positive r value, and so it takes a little bit of work to get there. Okay, so but those are the 2 values that you would need from that. Make sense? Ish. Okay. Let's stop there and work on some homework. This one won't be due tomorrow because ACT people are gone. So probably looking at Wednesday on this. Then we have a block day coming up, right? On, I I can't remember what day. I'll have to check. Tomorrow's Wednesday. Oh, did I say it's due Wednesday? Yeah, so this would be due,
Thursday was gonna be here.
I think it'll be Friday, right? 1-3-5-7-2-4-6-8. So probably Friday will be due, and probably an MCA Friday.